right, hello everyone. I'm here to present on SQL on FHIR and what's new and what's next for 2025. Okay. Hi, I'm Arjun Sanyal. I'm the head of product at Vermonster, Reason Health, and I'm presenting today on behalf of our little group called the FHIR Analytics Collaborative, and I'll talk more about that later. So in this talk, it's very brief, but I'll be giving a brief introduction on why we created the SQL on FHIR standard and a little bit about how the standard itself works, and then what we're working on currently and what we see into the future. So one question for you, I just wanted to ask, can you just raise your hand who feels relatively familiar with SQL on FHIR as it is today? Okay, so a lot of newbies, that's fine. This is an introductory session. And then there'll be another talk by one of our close collaborators, FHIR, after this, and then a tutorial session after that with Nikolai. I definitely recommend sticking around for both of those sessions. Then you can really get a better understanding of SQL on FHIR. So what is the problem statement? What is SQL on FHIR trying to solve for? The problem is not a new one that we've come up with ourselves. It's really from the beginning of FHIR itself. FHIR resources are rich objects that reflect the true complexity of healthcare data, and that's what we want. But many real-world use cases want these simple rectangular tables. That's what the industry and the world runs on. So how do we go from point A to point B? And those rectangular tables can be something simple as CSVs or as large as analytics at scale at 100 million patient level. And then, of course, it's 2025 AI model training, which likes very simple data sets. Clicker. Another way to think about the problem is how do we interoperably tabularize useful sets of FHIR data across these very diverse systems and use cases. Tabular data can flow through many, many different kinds of systems and use cases, and that's what it does. So how do we match the complexity of FHIR data, this graph-structured data, nested data, repeating data, to these systems? And then another thing we'd like to do is connect FHIR to this modern data system renaissance. The advancements in data systems over the past 5 years have been spectacular, particularly thinking about things like data lakes or columnar data stores and the like. And so we want FHIR data to become just more accessible in more ways using more systems. Clicker. There we go. And a question is, hasn't this been done before? And it has. There are many specific vendor implementations of something like SQL on FHIR, but there's been a significant challenge with them. It's very obvious right at the start. They become very vendor stack or dialect specific, particularly when it comes to nesting and arrays. So SQL generally wants to deal with flat data, and the nesting and arrays of FHIR data is what really challenges these implementations. And then there are lots of trade-offs which we thought about over the past 2 years. We've been working on the standard. I'll just mention some of them briefly, but NoSQL is definitely an option, and if it works for your system or your use case, you should definitely use it. But there's always going to be significant trade-offs with any type of system, any type of flattening, but specifically any type of NoSQL data structures as well. And then you might want to imagine flattening all of FHIR data in a kind of automated fashion or mechanical fashion. We've thought about that as well. Many people have. And you're probably going to be pretty unsatisfied in terms of what the results is going to be. It's going to be very difficult, and it's going to be pretty unsatisfying when you think about writing a query against something like that. Another important point which I experience in the real world as well, is when you have these nesting in arrays, in particular when it meets the SQL language, this is a very challenging and difficult way to write queries for most SQL developers. Most SQL developers will never access, never do a lateral view explode on nest. And so what that's doing, if you take that kind of approach, you're saying the bar for SQL developers is very, very high. They require lots of training, lots of ways of thinking. So what we'd like to do is create a system where we can essentially pre-bake that and flatten it in advance. And so it's more accessible to more types of SQL developers. And then relatedly, a lot of FHIR and BI and analytics tools will just not work at all or work very poorly with nested array data, particularly Power BI being one of them. And so if you had an organization, you have a team with dozens or hundreds of developers who use SQL on a daily basis, they use tools like Power BI or Tableau, and you say, well, here's my solution, and it doesn't work for them. That's not a satisfying outcome. So these are some of the impetus for what we did with SQL and FHIR. So this is an example at the bottom of the difference between the dialects of SQL. So SQL is a standard. There's some standardization around nesting in arrays, but it's not really well implemented. It's this really crusty area of the standard and implementation. So just to get in your heads of why we spent time working on this problem. So this is an ideal context for a standard. Standards are great, but they also have costs. We just don't want to create them in a willy-nilly fashion. So if we have many similar ad hoc solutions, and we think there are probably a couple dozen SQL and FHIR implementations out there in the world today, and we have these challenges that we know are inherent in this problem, it's really ripe for a kind of ripe for standardization. And from myself and a product perspective, what we really want to do is not just create a standard. We want to unlock an ecosystem. We want it to be generative. We want new types of use cases to be developed against them. So that's really our long-term goal from my perspective. So what's the solution? We call it SQL on FHIR v2. You can kind of just ignore the v1 part for now. It's not really super relevant, but so it's called SQL on FHIR v2. We've been working on it as the FHIR Analytics Collaborative for about 2-ish years now. And it looks like the clicker works. Well, one other thing I want to mention before we start looking at what SQL on FHIR looks like. The way we thought about it, and we really wanted to have a separation of concerns here. So read this from bottom to top. The bottom part we call the data layer, which is these lossless representation of FHIR resources. In a way of, there's things you can do in the data layer to make FHIR data essentially enrich it, to make it more useful for these types of analytics. But it's a lossless transformation. You can transform to and from. But that part is an optional part, right? You can just use regular FHIR data. I'll mention it in passing here. Where SQL on FHIR, the specification focuses on is what we call the view layer here in the middle. And then on top of the view layer, once you have flattened views of FHIR data, is the analytics layer. That's where you write your queries or use your BI tools. So we don't talk very much about that part, the analytics layer. That's up to you. So we're really focused on this part in the middle, the view layer. And one of the design trade-offs, the major design trade-offs that we focused on was ease of implementation versus the expressiveness. There's a lot of things you can imagine or think about in this space, but we really did focus on a very small set of concerns and really wanted to nail them. So if you don't remember anything from this presentation at all, what is SQL on FHIR? If somebody asks you what SQL on FHIR is, there's one sentence here: portable, interoperable, tabular projections of FHIR resources. And the way we achieve that is through this main artifact here called the view definition. Probably faster. And what the view definition is an interoperable, self-documenting, technology-independent expression of flattening choices. I have 5 minutes left? Or I've done 5. Do I have 5 minutes left? Okay, wow. All right, well, we're going to skip way ahead. Okay, all So you write view definitions, and you also write a view runner, which is a system-specific tool for your specific data environment. So this is showing the view runner that runs in the web browser, and that's a JavaScript-based view runner, but there are many view runners. It's actually not very difficult to write one. Many view runners have been written, and they're about under 500 lines of code. So you have your data in your data system. You have a view runner, which applies the view definition that you created on your data system. And then you have something like this. So looks magical. So that's it. I mean, that is what SQL on FHIR is in a nutshell. So I go into some of the technical details, but we'll probably have to skip ahead a little bit. So I'm going to skip through some of this stuff. So this is what it looks like in practice. You have a FHIR resource on the left, SQL on FHIR, and you want a simple table on the right. So view definitions are logical models. This is a sample view definition of what it looks like. And so if you read through this, it shouldn't seem too unusual to you if you know SQL fairly well. Like I said, I'm not going to go into the details. We can go into them later as well. The main part of a view definition is the select expression. This is what really encodes the flattening choices. View definitions use and leverage FHIR and simple FHIR expressions. And so if you are familiar with FHIR, it's a very natural fit to write select expressions using FHIR expressions. And we use the for each stanza is what unnests the repeated fields. So this is how we solve that unnesting array problem. I'm going to skip through some of these to talk about what's new. And all right, so what's new for 2025? So what's new in 2025 is the 2.0 release of SQL on FHIR. It's being used, it's being developed, view definitions and view runners are being developed. It's being used in more and more implementations. And so we're very excited about that. The FHIR Analytics Collaborative put together an online conference, and we'll have more events specifically around SQL on FHIR and FHIR Analytics in general. So keep on the lookout for those. View definition support was added to IG Publisher. So if you have IG Publisher, you actually have SQL on FHIR to be used for specific use cases within IG Publisher. But that's a way you can potentially get started with SQL on FHIR. And then I just listed out a number of things that we're working on or what's new in 2025. There's an approach being taken for mapping FHIR to OMOP using SQL on FHIR views. And then there's new tooling coming out for the graphical view definition authoring, things like patient collection, patient cohort selection, and then coming up right after this, LLM-powered query over SQL on FHIR views by Bashir. And I just want to touch on a couple of points at the bottom. So we're going to have more implementations. So currently there are 9 implementations that we know of, but there's probably actually some more out there. So if you have a SQL on FHIR view definition view runner, let us know about it. And some exciting ones like FlatQuack, which uses DuckDB, and different types of implementations. So in memory, in database, streaming. So this is a simple architecture that can be used in different environments. It's not really fixed to one, so you can use your imagination in the way you want to use it. This is a big one, so I want to take a minute here. FHIR APIs. So view definitions, we're creating FHIR APIs in very active development to adding them to the spec. So things like discovery of view definitions, understanding their capabilities, bulk export, real-time evaluation, things like that. So if you think this is useful and you'd like to see APIs for this, you'd like to help define them, please let us know. This is in very active development right now. Another exciting new development is Parquet on FHIR. So remember, we talked about those layers. This is in the data layer. So there's a draft specification for the encoding of FHIR data in Parquet to really make this usable for these columnar data stores and different use cases where Parquet might be very useful. So it really does, we're really looking at starting to unlock this kind of big data scale, performance, and capabilities. And then lastly, I think this is the last one, we're really interested in taking these concepts and moving them to the next level with ideas around how can we start to encode the query side itself, so kind of that analytics layer on top. But how can we make queries interoperable and portable? We have this infrastructure they can run on now, but can we make them portable artifacts? And then even beyond that, potentially, could we make the whole concept of kind of an analytic or an analytic case become portable and interoperable? So this is another really interesting active area of development that we're working on. I'm super excited about this one in particular. So I've got some calls to action for you here, but I know we have to wrap up. But let's see. Okay, make your own implementation, get involved. This is a totally open group. We chat all the time. Please come and talk to us. And yeah, tell your friends, tell your boss. Think about how you can use SQL on FHIR and the things we talked about today, and we'll talk about a little bit more, for your high-value use cases. So that's our ask to you. And thank you from the FHIR Analytics Collaborative.
Thank you. Got a few questions online.
Sure.
How many open source and performant implementations currently support SQL on FHIR?
I mean, that's a little bit of a loaded question. I mean, there are probably, I would say, there's more than 5. I would say maybe 6 or 7 open source implementations of SQL on FHIR. We haven't really rigorously measured performance, but we think it's probably quite good. We're not seeing lots of performance challenges. So there's definitely a lot of options for you to look at in the open source community.
Thank you. And I think there's another question. Will SQL on FHIR potentially replace CQL? They seem different to me. But.
That is not a goal of SQL on FHIR. SQL on FHIR is really focused on the tabularization of data. That's, we use CQL. Lots of people use CQL. We see them as collaborative standards.
One more question, then I'll go to the audience. Yep. How does SQL on FHIR work in terms of being a replacement for FHIR search?
It's not a replacement for FHIR search either, right? So we could definitely see FHIR search being remaining what it is. We don't intend to replace FHIR search or anything else. We want to work with it. I think that question might be related to the APIs as well. So, in the sense that if you wanted to have a query over your data, right, maybe a SQL on FHIR API might be more helpful to you in terms of FHIR search, but they're not in conflict in that way.
Any more questions in the audience?
Hi, thank you for the talk. We've playing around with SQL on FHIR a bit, and currently our challenge is a bit, how do we exchange those view definitions until they are standardized in the FHIR API? So we want to change them as a company with hospitals, as a good starting point for useful queries.
Yeah, that's a great example of what we are currently working on today. So I would definitely take a look at the work being done on the specification. Of course, this is all in the open as well. You can read it, you can comment on it. In terms of, the view definition is a FHIR artifact. It is a logical model. So you can exchange those artifacts in any way you exchange artifacts. But I think quickly you'll say, potentially I want to do more beyond that. And so the API that we're developing and these ideas around a query resource might be interesting to you.
All right, we have time for one last question.
Yeah, on the Parquet on FHIR slide, you said and back. Can you just say briefly what's the and back? Is it like structure maps, or how is the and back happening?
I'm sorry? The
and back on the FHIR on Parquet, you said, to Parquet and back.
Yes, correct. Yeah, so the way we're designing the Parquet on FHIR implementation is a lossless transformation that can go both to Parquet and back from Parquet. And so, yeah, there are implementations of people mapping FHIR data to Parquet, but we want to standardize that, right? So that they become more interoperable. But yeah, it should be a lossless transfer, replace or repeatable transformation. So again, my pitch to you guys is, if you're interested in this, all this work happens in the open. Please come and talk to us. Please come and collaborate with us. We'd love that.
All right. Thank you so much.
All right.